Alright, so here's my third video on Laplace transforms. We're going to be evaluating them. So the Laplace transform of some function f of t is equal to the integral 0 to infinity of e to the negative st times your function f of t, the function that you're taking the Laplace transform of. And we're integrating with respect to t. Alright, so let's take a look at this example here. I'm going to evaluate the Laplace transform of sine 2t. Alright, so I have the Laplace transform of sine 2t. Okay, so that is going to be the integral from 0 to infinity of e to the negative st times sine 2t, and I'm integrating with respect to t. Alright, so to integrate this, we're going to have to use integration by parts. Alright, so let's see what happens here. So I'm going to let u equal sine 2t, and so du is equal to 2 cosine 2t. And then dv, I'm going to let that be e to the negative st, e to the negative st dt, and so v is equal to negative 1 over s e to the negative st. Alright, so this is going to give us u times v, so negative 1 over s e to the negative st times sine 2t, and I'm going to evaluate this from 0 to infinity, minus, now that's going to be du times v. So you see how we have the negative 1 over s? That's going to make this plus, and so 2 times that, that's going to be 2 over s. I'm going to bring that outside the integral, 0 to infinity, and then that's going to be e to the negative st cosine 2t dt. And this, when I took the derivative, that should be times dt. Alright. Alright, so let's look at this. Let's see if there's something we can do before we go on. Well, if we look at this part right here. So if I take the limit as t goes to infinity, okay, this is going to come down into the denominator, and that's going to change it. It's going to look like this, negative sine 2t over s e to the st. Okay, now as we're going to infinity, sine 2t, all that's doing is what? It's going back and forth from negative 1 to positive 1. But this denominator here, it's going to infinity. It's getting really big. So this whole thing is going to 0. Okay, and then if I plug 0 in, okay, so remember, as I go to infinity, that's 0. Alright, and then if I plug 0 in, well, that's 1, and then the sine of 0 is 0, so that would be 0 also. So I would have 0 minus 0, which is just 0. So this whole thing here just goes to 0. Okay, so maybe that'll make it a little bit easier on us. Okay, we won't have so much written down. So let's just rewrite this as 2/5 0 to infinity e to the negative st cosine 2t dt. Alright, now we integrate this. Well, we'll use integration by parts again. So I'm going to let u equal, well, that's going to be what? Cosine 2t So du is equal to negative 2 sine 2t dt. And then dv, I'm going to let that be e to the negative st dt. So v is negative 1 over s e to the negative st. All right. So this is equal to, now I guess what we're going to do here is let's maybe just write down the 2/5 and then put that times and now let's do our integral. So that's u times v, so that's negative 1 over s e to the negative st times cosine 2t, right, minus, and so when I multiply the du and the v, well, that's a minus and a minus is a positive, so that's going to stay negative there. That's going to be 2 over s. I'm going to bring that outside this integral, 0 to infinity, and then that's going to be e to the negative st sine 2t dt. Alright. Oops, I'm sorry. That's 0 to infinity. Alright, so this is going to give us 2/5 times, now let's evaluate this. So as t goes to infinity, well, that's going to be the same argument that we had here when we did this as t goes to infinity. Just like sine, cosine is going to be going back and forth from negative 1 to 1, and then this is going to get really big in the denominator, so that's going to go to 0. And then I have minus, and then when I plug 0 in, okay, so we plug the 0 in, well, that's what? Cosine of 0 is 1, that's 1. Well, so this is just going to be negative 1 over s, okay, minus 2 over s, okay, so I got 0 minus negative 1 over s minus 2 over s. Now what about this? Well, actually I would have to use, I can't really integrate that, I would have to use integration by parts, wouldn't I? But look at this. Well, see, notice what I have here, e to the negative st times sine 2t dt, and that's the integral as we go from 0 to infinity. Alright, we'll come up here. The integral from 0 to infinity, e to the negative st sine 2t dt, what is that? That's the Laplace transform of sine 2t. So I can take this part right here, and I can replace it with the Laplace transform of sine 2t. Okay, so that's going to be 2/5 times the Laplace transform of sine 2t. Okay, so it looks like we're getting somewhere now. Let's distribute the 2/5. So that is going to be, I'm sorry, not the 2/5, but 2 over s. 2 over s. So when I distribute that, that's going to give me 2 over s squared, and then minus 4 over s squared times the Laplace transform of sine 2t. Alright, so what do we do now? Well, look at this. This is equal to what? Well, let's go back up here. This right here is equal to the Laplace transform of sine 2t. See, we did this all the way down. The Laplace transform of sine 2t equals all of this. So I can actually come here and write down the Laplace transform of sine 2t is equal to this right here, 2 over s squared minus 4 over s squared times the Laplace transform of sine 2t. And so all I do now is just solve for Laplace transform of sine 2t. So I'll bring this to the other side. That's Laplace transform of sine 2t plus 4 over s squared times the Laplace transform of sine 2t equals 2 over s squared. And then I'll factor out a Laplace transform of sine 2t, and so that's going to leave me with 1 plus 4 over s squared equals 2 over s squared. Divide both sides by this, so Laplace transform of sine 2t is equal to 2 over s squared divided by 1 plus 4 over s squared. And so I know we still remember how to simplify this. I'll just multiply each term by the common denominator. And so I get the Laplace transform of sine 2t is equal to 2 over, and that's going to be s squared plus 4. And this would be your solution. Alright, so sorry about the few mistakes. You get the s's in there, they start looking like 5s. So but I hope this video's helped. If it did, you can watch my other videos and subscribe. Alright, thanks.